The SETI Institute's listening station is nestled in Hat Creek, California, on an old lava bed. The valley and surrounding mountains block nearly all of Earth's man-made noise, providing a perfect listening post for alien messages, assuming they're sending any.
It's a great thing because we look for natural sources of radiation, and any kind of man-made terrestrial radiation is a problem for us. The piece of equipment behind me is an antenna, one of the individual elements that will comprise the 350-element Allen telescope array when it's completed.
The listening post consists of an array of radio telescopes resembling satellite dishes. They collect radio radiation from space. Among all the noise frequencies out there, SETI listens most intently to microwave signals.
There's a good reason for this. It turns out the universe is darkest and quietest at the microwave wavelengths. And so it's the prime channel, if you will, for interstellar contact and communication. In fact, we use this channel to communicate with spacecraft for the very reason that we can do it most reliably with the least expenditure in equipment and energy.
There's another practical advantage to microwave radio signals.
It turns out that it doesn't take very much energy to send information via radio from one star system to another. And also, radio waves go right through the gas and dust that's between the stars. If we know that, they'll know that.
So what is the SETI Institute listening for exactly?
A narrow band signal, which is just a signal that's at one spot on the dial, because transmitters make narrow band signals. We're not looking for the message. We're not looking for, mathematical equations or anything like that. We're just looking for a lot of radio energy at one spot on the dial.
Listening for aliens wasn't the SETI Institute's idea. Inventor Nikola Tesla first searched for extraterrestrial radio signals back in the 1890s. Soon followed by Guglielmo Marconi. Both believed that they'd heard something.
And indeed they did. Something that sounded very intelligent in its nature, a sort of chirping sound coming in the radios. It turns out that this was a natural phenomenon, energetic particles moving in the magnetic field of the Earth.
But it wasn't until the late 1950s that developments in radio telescopes and receivers allowed us to listen carefully to the stars. And astronomer Frank Drake was one of the first scientists with his ear directed to the heavens.
In the late 50s, I constructed the first system and carried out the first search of this kind at the National Radio Astronomy Observatory in Green Bank, West Virginia. It used a 85-foot radio telescope, and we used it for 2 months to search for signals from the two nearest stars like the Sun, Tau Ceti and Epsilon Eridani, with very high sensitivity.
They didn't have to wait long.
The very first day when we pointed the telescope at the star Epsilon Eridani for the first time, we heard a chirping sound in our radio receiver, something we had never heard before. And it was very exciting, as you can imagine. We thought, can it really be this easy? You just turn the radio on, point it at a star, and there it is. Before we could establish the actual origin of the signal, it disappeared, and we had to follow that for weeks, hoping for it to return, and finally it did. And it turned out to be from one of our airplanes, but it was an exciting moment.
There have been others.
In 1977, Ohio State University's radio observatory actually picked up a signal which has become famous. It's called the WOW signal. And the reason it's called the WOW signal is that Jerry Ehrman, who came in and found the signal after one night of recording, he was just flipping through the computer printout, and he saw this big signal there, and he wrote WOW next to it. Some very careful searches have been made to try and find that signal a second time, but it was only seen once. And unfortunately, as a scientist, you have to say, well, if I can't confirm it, then who knows what it was, and I can't claim that it was ET.
So far, no credible alien transmission has been received in any SETI search. But we do know for sure that intelligent creatures, hitherto undetectable and within our own galaxy, have sent signals into space for years. they would be us. Our earliest radio and television broadcasts are now light years away. Aside from these unintentional broadcasts, we have sent one very clear message in 1974 from the most powerful radio telescope transmitter in the world, the Arecibo Radio Telescope.
We sent a signal which lasted 3 minutes and is coded in such a way that the extraterrestrials can construct a crude picture from it, a picture which starts by establishing a number system. It then shows the chemistry of the key molecule of human life, DNA. It shows a sketch of the solar system. There's a sketch of a human placed in such a way that you can tell it lives on planet 3, which is the one we call Earth. Today, it is on its way to a great globular cluster of stars known as Messier 13. It will arrive there in about 25,000 years.
Who might hear that signal some 25,000 years from now? What sort of commotion might it create? Is it similar to what they'd send us if they could? Maybe that's the wrong question. Maybe what we should be asking is, why do we care whether they're out there or not? Why do we seem to be reaching out to them?
You could say, oh, it's because of all the movies and the television shows about aliens, but I think that that's actually a consequence of our interest, not a promoter of it so much. I think that we're inherently curious about other beings that might be comparable to us in abilities, and in this case, maybe far beyond our abilities. I think that we're wired to be interested in other intelligent beings. So, in a way, it's curiosity, but I think it's curiosity that's born of evolution, really.
It's in our genes to be curious about the unknown. Real or imagined, our alien visitors help us conceive new worlds, not just on distant planets, but right here on planet Earth. At Fermilab, at the SETI Institute, and in the classrooms and laboratories of physicists all over the world. We've been inspired by the unknown to contemplate solutions to problems we might not otherwise have considered.
There's really two different ways of looking at science. One says, well, how does the universe really work, and how do we know? And the other way of looking at the world is, how could the world really work? And what is it that we don't know?
We know a lot about our universe. Still, there's so much more to learn, and so many other places to go.
It's tragic. There's this whole universe to explore, and we're stuck here on Earth. We haven't even left the solar system. And so it's easy to hope that one day we will be able to travel throughout the galaxy and experience directly all its wonders.
And perhaps one day we will.
Tomorrow at noon, it's the UFO file marked Canada's Roswell. Next, the iconic wartime American PT boat is at battle stations with archive footage and the memories of those who manned this heavily armed craft.